And then banks with good capital reserves might have good performance, but it could be the other way around. That well-performing banks can afford to have adequate reserves. When I was a runner, they thought that lactic acid was killing you, right? You had to do, we did everything we could to prevent lactic acid buildup in our muscles. But when they studied it at a molecular level, that is structural information, they found the lactic acid was actually helping, right? So there was completely the wrong inference, the wrong causality they were finding. So you can't just do a regression and establish causation. Right? So we've got to talk about what the editors are looking for you to show causation. You're going to get this all the time. You send it back. If you just run a regression, tell a story, they're going to say, no, that's not what we're looking for. So what is the econometric fix? And I've got to say up front, the econometric fix is not going to do it for you, right? The editors aren't happy with just the econometric fix. They want something more. They want this reduced form. So the econometric fix is to use instrumental variables, right? Something that's uncorrelated with the error. And I'll give you some examples of this, but relevant to the thing that you're measuring at the workflow. And then instead of the estimator being covariance y with x over variance of x, the estimator becomes covariance y with z over covariance x with z. I'm not pointing to. So you can actually test for endogeneity, right? So you can compare the coefficients you get from OLS, which is maximum likelihood, with the coefficients you get from instrumental variable estimation, and that's known as the house on root test. So it might be, I think you might have endogeneity, but you can test for it because we have it. And then you can do the two properties of the instrument. You can see whether the instrument is correlated with the potential endogenous variable, and you can also see whether the instruments are uncorrelated with the error. So examples of instruments. Well, they're very hard to find. If you come up with a good instrument, you might make the editor happy. Here's some examples. There's only like 5 examples that I can find. The only one I really sort of think is good is the second one. The instrument is the sex of the firstborn child. And that seems, you must be thinking, what the hell is he talking about? Well, it's, they want to look at the effect of family succession on performance. So they use as an instrument the sex of the firstborn child. So first of all, the family succession is likely to occur when the child is 40 or 50. Do you think something that happened 40 or 50 years ago by chance, that is a male or female, would be relevant to performance now? Something that happened by chance 40 or 50 years ago would be uncorrelated with performance now. So it's uncorrelated with the error. The second question is it correlated with the family succession? Well, unfortunately, yes, right? And particularly in Asian cultures, if the sex for the firstborn is a male, then it's more likely to be a family succession, right? So that's a really, really good instrument. And that the author there is a colleague of mine, Casper Nielsen, who does some very, very good work around because in the shop. But let's talk about the problem, right? We'll assume we know the frontier between ownership and performance. Yes, so insider ownership and performance. We've got three companies there, A, B, and C. Each optimizes, endogenous but optimize the trade-off between ownership and performance. You can see that A has a maximum of 3% ownership, B maximum at 7, and C at 5. Right? So now, say the US Senate decides to, sponsor a study, says, well, let's hire this year's swiper from Chicago to go and do a regression of ownership of the form. They go and do the regression and they find that performance is increasing in ownership up to about 5%, then deteriorates and then kicks up again. So that did happen. But this didn't happen. The Senate says that, well, everyone has to have 5% ownership. Well, clearly that's false. Now that occurs, you can see that A curve where it cuts to 5%. That would be the decrease in its performance. And you see B curve where it cuts to 5%. That shows you the decrease in its performance. So this would be a very bad thing, right? Because it would reduce the performance of A and B. It leaves C unchanged. So in contrast, if you did the right econometric fit and did the right IB, you would actually get this flat line. So at least you wouldn't make the wrong conclusion. You wouldn't make the wrong conclusion. So all of this was still followed by a guy called Denson way back in the 80s. And so he's saying, look, if you got those in 80s, there's really nothing you can do about it, right? You can't go out and do a cross-sectional estimation. Coles, Lemon, and Mansky said the same thing, but they did one of the first structural estimations. So they went with a structural model, which was principal agent with a production function, right? And looking at the productivity of labor. So the productivity of labor was a key input into ownership, right? If the labor is particularly productive, then it makes sense to have inside ownership. So what they did was they calibrated this model to the company's financials and then found the one with the most ownership had the most productive labor is most productive. So that's one of the first examples of structural estimation. Now, I will tell you, if you went out and just estimated a production function with the principal agent model, and that was the whole paper, the editors wouldn't like that. But they liked it because you've shown causality in a reduced form, and then you go and answer what questions with an accepted economic model. Not to say the economic model is verified by the data, but this is the economist thinks the best way of thinking about problems, right? Principal agent production function. So hydrolinquist is a very good example of doing reduced form estimation. So essentially that's a natural experiment. So they're looking at factors. So there's probably been 1,000 factors that right? But what they did was something unique. They went and hand collected data on state. They looked at tax changes. So it turns out, in the US, the states have tax somewhere between 5 and 12%, right? So quite significant. And of course, in Australia, we used to have state taxation, but the states surrendered their taxing power to the Commonwealth around the Second World War. So they went and found lots and lots of examples of increases in state taxes and decreases in state taxes. So there's only 50 states, so the 25 states they found 38 increases. About 2,000 firms split between 2 decades, and 29 states that decreases, nearly over 7,000 firms, and a pretty even split between the decades. And so they went through a lot of trouble to show that these changes were exogenous. They looked at firms across state lines, to seeing that they were doing basically the same as the one in the state. So nowadays they would call that the parallel trends, with the treatment experiencing not the same, but something in parallel with the control. So they actually found that a increase in income tax results in more debt being issued, right? So, which is consistent with theory. They didn't find that they were decreased, that they reduced it. But what I'd say to that is that you know, it takes, you can issue more debt immediately, but to retire debt is a different process. When people buy corporate debt, they're actually buying it and they want to hold it to maturity. So they wouldn't be pleased if you retired it early. So you sort of have to wait until the debt retires, you know, comes to the end. And then, you know, then not issue more debt if you want to reduce your debt. So outstanding paper, yeah, and the way to deal with heterogeneity is to do this natural experiment, yeah, and even though there's been like 1,000 papers, was the deal easily the best. So a way to do a natural experiment is what's known as a different dip. Yeah? So you have the exogenous event, there's tax change, you have the time the tax change occurred, you have a treatment dummy for the states that change the taxes. And then you do a regression, is your reduced form. There's no theory here, it's just reduced form. A dummy for time, a dummy for treatment, and then the interaction. The dummy for treatment and time after plus control. So the difference is just the difference estimator is the B3. So the B3 is what you want to report. That's the thing that's crucial to your empirical result. Okay, so now though, editors aren't quite happy with that. They want you to check parallel trend so that the treatment and control were somewhat the same. They don't have to be the same. There could be like a gap, but it was wholly parallel. And if there's multiple time periods, like here, they did 2 decades. They want you to account for that. So essentially, it's averaging. So you either average equally across those years, or you weight the years by the number of treatments in each year. So that's what they're looking for there. So that is now called reduced form estimation. Doing the natural experiment with the different dips is called the natural experiment. So what Cole, Lemon, and Mesky did with their principal agent and production function, that's called structural equation. You estimate the theoretical model and calibrate it to the reduced form. So here's an example, right, of a current, what the editors will do. So these guys get a lottery. You know, if you win the lottery, you get 150,000 lump sum. So they wanted to see if winning the lottery had a effect on your propensity to participate in the stock market. So they did a natural experiment, standard different dip, and they found that in fact it did have an effect. You were more likely to participate in the stock market if you won the lottery, right? So, but that's just the reduced form. So then the editors wanted more. So then they said, well, look, we're going to fit a theoretical model, the life cycle model, right? And why do the editors want that? They want to be able to answer what is question, right? They probably don't believe that the life cycle model fits the data exactly, but it's a best way of thinking about the issue economically. So we calibrated to the reduced form. Then we can answer questions like, how do the parameters affect the outcome? You know, how, you know, why is driven by each of the parameters? And what if we change the parameters, right? That's the policy parameter. So they want to be able to answer these wide questions, and that's what's called structural estimation. So once you've done the reduced form, you need to pick the most relevant structural model and calibrate it to the reduced form. So you see here, Tony Whitted, the editor of the JFE, and here's 2 different lectures she gave on reduced form and structural models, right? So definitely what's in, because the editors are telling you, they're being very kind to you. They're saying, this is what we want, We want to see the disform estimation, show causality. Then we want the structural information to be able to answer the what if question. So, yeah, so you can try to get intuitive, economically motivated instruments. You've got to find that very difficult. So it's probably best to try, but whatever your problem you're looking at, try to get it in natural experiment mode. So, for example, China is getting a lot of papers published in the top down, right? And why? Because before they introduced a new rule in China, they test it by having pilot plants. So they might try it out in, say, 5 or 7 provinces. So that gives you a treatment. Then you find control provinces, right? That's the natural experiment. Then you get the structural model. So that's a really good example. So looking around Vietnam, are there things that the Vietnamese government has tried? And then that you automatically in a natural experiment. And so they want to see reduced form and they want to see the structural experiment. So what about announcements where there's uncertainty? So for example, a takeover is announced. So, everything you've heard about takeover, what the bidder gains and what the target gains is wrong. Right? They're treating it as if there's no uncertainty. They're looking at an event that just the change in the price of the target and the change in the price of the bidder. Right? But when the takeover is announced, there's various parameters to estimate. Right? One is the probability of the takeover being successful, the bidder price is successful, the bidder price is unsuccessful, the target price is unsuccessful. So there's quite a few parameters, and you can't just identify that with the change in the bidder price and the change in the target price. Right? You need to get some more going on to get identification. So you have to identify all of those parameters. So the Barraclough does a really good job looking at this with takeovers. And there's another paper following on about Obamacare. So Obamacare is announced, but there's like, what chance is the probability of getting passed, and then what effect will that have on health industry companies, medical companies versus other. Gillard carbon tax announced the carbon tax, but it was unlikely that it would get to Parliament. It was only the independent that voted for it, so you can look at that. Class action lawsuits and regulator action. And so, class action suits occur, there's probably a success, and then you can look at what the company's value will be if it succeeds, if it doesn't. And the regulator, SEC, brings action against the company or the probability of success, what's the value if it succeeds, what's the value if it doesn't. So here's the takeover. So you can see the target, and that's the regular event study, and that's the bidder on the right. But we've got to identify the probability of success. Right? So you can't just use the one price change to identify all of the parameters that are necessary. So the new information released by the takeover bid. So we need to get, what's the information effect, what's the value effect. Yeah. So looking at the bidder, that's what they eventually tend to show. But this is the underlying, once you allow for the fact that the probability, there's a probability of succeed. So the value that you see is a weighted average of the probability times the price if it fails, plus the rest of the probability times the price if it fails. And so you can look at the change in price from, now we've got the two prices, if it fails, it succeeds. So you can see there's news about the bidder, and there's also the gain to the bidder, right? So lots of times the news can be negative, right? For example, Amgen was the largest pharmaceutical company in the world, announced the takeover of a very small cancer drug company. And the analysts looked at that and said, what the hell, what's the biggest pharmaceutical company in the world trying to take over this little cancer drug? And the analysts had valued the company as if it had the intellectual capital to handle all sorts of drugs, right? But when they looked at the portfolio of drugs that Amgen had, they were really mainly around anti-rejection of organs, etc. They didn't have a single cancer drug. So they decided, whoops, they don't have the intellectual capital to do cancer drugs, right? And that news, reduced the value, but given that they didn't have the intellectual capital to do cancer, acquiring a cancer company was good news, right? So there was positive gains from the takeover, but negative news. So that's like a good example. So how would you go about doing it, right? So you've got one price, but you've got three parameters there. Probability of success, bidder price if it succeeds, bidder price if it fails. And if you put them together, you can see that, here we go. You get the gains to the bidder firm, the news about the bidder firm, the gains to the target firm, and the news about the target firm. We'll make these slides available to everyone. And the total gain are the gains to the bidder and the gains to the target. So how do you identify? Well, we said there's three unknowns: probability of success, the bidder price of successful, the bidder price of failed. So, but there's only one stock price, so we need to augment the equation set. So what you can do here is use call options that will augment the stock price information. So you've got an observed call option, and so well, that's the probability weighted average of the option price to succeed plus the option price to fail. Now, notice we introduced new parameters, two new volatility. Volatility to fail, volatility to succeed. So now I have 5 parameters. So we need the stock price change plus at least 4 options. Now, you might say, well, is it really identifying? Because aren't options redundant securities? Well, the volume of options for the target increases by over 1,000% on the takeover announcement, and for bidders increases by over 400%. So it looks like information is flowing through the option prices. And then you just estimate those equations. You've got you get identified the various equations, and so you can separate out the you can separate out the gain and the information. So, yeah, so to identify the possible 5 parameters, you need the 4 call options, and is this information relevant? Well, we can see the dramatic increase in the volume. You want the options to have a long enough time to exploration, so they, go past the time when they're starting to evolve. So, what are the editors looking for? They're looking for causality, and they want to see both reduced form and structural estimation. And when announcements have unresolved uncertainty, they want you to take account of that one so that you can estimate the probability of success and also the values under the different alternatives. And so we are open for questions.
Like to the finance, from corporate finance to finance, a lot of topic, and the major issue is the who know actually for why. A lot of things in between. So how we solve the relationship between us for why? Is it a correlation or causation? And a lot of sorry, a lot of and questions.
Yeah, it used to be you could run a regression story.
Yeah, so we live in the period training for regression. So we need more power.
Yep.
Okay, so
Well, if you come up with the idea of right, being from what they're really what the research on. But then you look at what's the growing country, but well, it's like not really research that here. So let's look at with that time, and they might have a pilot zone for the areas of like index zone, sustainability zone, carbon trading zone. Or, and you might find something that's parallel to what you do, which is useful structural information. Then what you can do is do structural information in Vietnam, right, using the theoretical model, calibrated on time. That might always occur, but there's a lot out there. And look, thinking outside the box, the 1,000 papers on this taxes, before hydroelectric. I thought that was what, so one of the hell would be just federal taxes. Why don't we go with state taxes? So just thinking outside the box, it might be a possibility. You can test the theory if you want to do, what you want to do. But they start with that first and then see if you can find that.
Thank you. That's very inspiring. Thank you.
Different.
Well, I'll be around making the I might be shy about the question here, but I can come up to me at conference, 25 minute conference. We'll make these slides available to everyone. Yeah. It's really important that you do know about this because this is what now there is the two models, and we want to see you do the work and get published. If the editors have gone to the trouble of telling us that we need to give it to them. I mean, you mentioned how you would feel if you told people what to do, but they don't follow your advice. Oh my gosh, what do I do to get them to believe?
Yeah, Prof. Smith still be here for a couple of days. Yeah, provide have a question or have research idea or any research interest that you can come to Professor Smith. And I'm very pleased to contact you.
So we do a national PhD course on different research methodologies every year. And Duke is here with Dr. Duke. Dr. Duke will be contacted and send you the details. We had like 14 students from Vietnam doing it this last year. you, learn all about the different methods, qualitative, feeling, Alexander, survey, experiment, systematic reviews, and, econometrics. And you get to do a research proposal and you get comments on it. So that's what we're doing. It's going to be held in the third week of July. The 10th of course. And you can do it on. And we make friendly hours, so you don't have to get up 4 o'clock. Okay, thank you.
Hello everyone, probably we take the short break, 10 minutes before we come back to the presentation of today's topic. We are going to the 10:17.